And we're live?
We are live.
All right. Hello, everyone, and welcome to today's kickoff session for the EscarpCon. Today, we're presenting EscarpCon Day 1 of 3. So we got a few days of us doing this. Today is all about fermentation innovation. So Escarpment Labs, just so everyone who isn't aware, we are a yeast producer located in Guelph, Ontario, Canada. We work with breweries all over the world to solve fermentation-based problems and explore flavor opportunities. We're not just Canada, we're all across the world. I'm Nate Ferguson, co-founder and director of production at Escarpment Labs, and I'll be your moderator for today's webinar. Now, today our topic is a rather exciting one. It's all based on non-alcoholic craft beer production. I'd like to introduce our presenter today, Chris Saunders. Chris is our quality assurance technician at Escarpment Labs, where he focuses on assuring that the product reaches professional brewers across Canada. He also has a background in software, which has allowed him to help improve and automate our business processes. His favorite beer styles are Weiss beer and Bavarian and Bohemian style lagers. For those joining us, please feel free to start discussions in the Crowd Class platform, ask questions and upvote questions in the features located in the platform here. I'll do my best to monitor the discussion throughout today's talk, as well as address those questions at the end of today's webinar. For those turning in live, please use those options. We will be answering the question at the end, and all of this will be available on YouTube, which we'll post later on. So without further ado, Chris, you can take it away. Tell us about alcohol craft beer production.
All right. Let's make sure I've got the right window here. All right, cool. Okay, so here we're going to be talking about non-alcoholic craft beer. So we're going to be mostly discussing the challenges in flavor and safety. So just as was mentioned, we're a Canadian yeast supplier with offering fresh, locally made, ready-to-pitch liquid yeast, provide a wide range of services, including micro quality control, custom yeast and bacteria, and strain banking. And we strive to be excellent sources of knowledge, and our focus as a company is on quality and education, which we're expressing through things like these webinars we've been running. So previously, I was a lab technician for Escarpment Labs. Now I'm in a business development role. I started investigating low alcohol, no alcohol beer in mid-2018 after I came back from Germany and from a trip in Germany. And I've also helped Escarpment develop a propagation technique for non-alcoholic yeast species such as Saccharomyces ludwigi. So on the agenda, why do we make alcohol-free beer? How are ways that we can produce worts for alcohol-free beer? How we can do alcohol-free fermentation, how to do post-fermentation handling, and then how to manage quality control for alcohol-free beer. So right now, if we just think about it, there are a lot of non-alcohol or non-beer alcohol-free alternatives that are out there. So kombucha and water kefir are some pretty big ones. We've seen those a lot. There's craft sodas. We've seen a lot of places, even some breweries will offer for a non-alcohol option. They'll just do kegs of kind of in-house made craft sodas, Italian sodas, where they're just making simple syrups, like in flavor-enriched simple syrups, and then mixing those with soda water and so on. So there are non-beer alcohol-free alternatives that do work, but sometimes that's not what people are looking for. Sometimes people want something that tastes like beer. And a lot of these alcohol-free alternatives also have a tendency to have higher, quite high levels of sugar in them. So alcohol-free beer, we're thinking, but why? So the alcohol-free market is projected to reach a value of $25 billion by 2024. For macro breweries, that much of this is in markets where alcohol isn't consumed at all. And from some of these, from some of the research, the market research, the second largest market is in Germany. And there's a number of reasons for this. There's cultural reasons, lifestyle, and health. A lot of alcohol-free beer has a tendency to be lower in calories, which is the added health benefit. And while I was visiting Germany, I saw it was quite common to see alcohol-free beer as an option. So we've got to look at those opportunities. If we take a look at the market right now, we've seen quite a surge in alcohol-free products being offered in Ontario. Partake, at least in Ontario and across Canada, Partake is a big one that's kind of hit the market in the last 2 or 3 years. Recently, Athletic Brewing, based out of New England, raised $17.5 million in a Series B round. We're seeing a rise of more craft alcohol-free SKUs. In Ontario, the Liquor Control Board has their retail locations have started dedicating areas to alcohol-free beer production. And then the newly developed, that looked into this, 2017 is when it came out, but the newly developed Heineken 0.0 uses a completely different manufacturing process than the other alcohol-free offerings that a lot of macro breweries use currently. So thinking low alcohol, lower no alcohol beer isn't the same process as making regular beer. There's a lot of things that are involved in that. Whenever we're making low alcohol beer, how do we maintain that beery flavor profile? Something that comes along with low alcohol beer is there can be lower material usage, raw material usage. But along with that, there's more critical control points that we have to be aware of, because depending on how we manage that product, we do increase our risks. And then there's quality control and product safety, which is something that we also need to be concerned with whenever we're thinking low alcohol. Some of you might have come here from the low alcohol talk that was given through the CVCs last week. I'm just going to mention their product because it is an option. You can use technologies such as vacuum evaporators to remove alcohol. This ABV technology product that was mentioned at that talk will take it. It's a process that you can install that will take a product like a 5% beer in and then turn it into a 0.5% beer out. The way that works is by using lower temperatures to help reduce that flavor impact. Historically, the technological approach to making low alcohol beer has been to produce alcohol-free pale lagers. That's generally what people were drinking anyway. And as we're seeing with this ABV product, more affordable craft solutions are hitting the market. So we can approach how to make low alcohol beer from a bunch of different ways. You can use small grain bills for lower gravity worts. You can do non-enzymatic mashing or cold mashing to produce low alcohol beer. This is pretty popular. I've seen in like homebrew. I haven't even thought of how to do it at a big level. And then there's steeped dark malts with sugars added to it that we can use to make low alcohol beer. So for small grain bills, this will follow your typical brewing process, but use less grain. Depending on the system you're using, you might have problems mashing. So with extremely thin mashes, you can possibly run into conversion issues. You might not need the lauter because after conversion, you can just add all your sparge water, boil off, and collect. But you will have extremely thin grain beds. So that is something to be aware of. And then another option is you can just produce 12.5 degree Plato wort and then send in hot liquor into your FV after cool out for post-boil dilutions. One of the problems with this is you can end up with reduced grain flavors. These beers can be thin and boring. That's one of the problems that come with this. The other way to go about that is to do non-enzymatic or cold mashing. So you're doing a full grist load at room temperature or cooler for 8 to 12 hours. What happens here is because you're mashing cold, the starches aren't gelatinizing and you're not activating those enzymes. So some starch will get collected, but a lot of it will remain in your grist. And then conversion happens in the kettle before you start boiling. So you use a lot of grain to produce a low gravity wort. And so there is a lot of waste here, but you can possibly recover a lot of that by using it as an adjunct for high gravity products. I've tried doing that like twice, and I had a bunch of conversion issues. But there is the possibility that you could create this low gravity wort and then take that and mash it and do re-enrich it with enzymes and then turn all that remaining starch into sugar for, say, producing high gravity beers like triples and stuff like that. The more grain results in beers that are maltier and fuller. Using standard Saccharomyces such as Cali Ale of Vermont can result in a product that's roughly 2 to 2.5% without any adjustments being made. So here's just a picture of what like a wort from a non-enzymatic cold mash look. So on the left is before wort conversion, and it is starchier. Like the wort's still pretty turbid, but the wort was like, it was clearly very starchy. And then I brought it up to 68 degrees Celsius and let it sit. Basically, I was checking it every 5 minutes for doing the iodine conversion test. Once that passed, I was like, all right, I'm done. And then I started heating it up to boil. That was about 20 minutes at 68. And then you treat it as normal. So then we can get into steeped malts with sugar. So for people who kind of got first into home brewing, maybe from like Palmer's How to Brew, there's one of the techniques you can do, which is steeped malt with extract. We're basically doing the same thing. So we're going to steep all of our darker malts, such as crystal malt and like roasted malts and stuff like that. Steep all of those. Those really contain no fermentable sugars. All we're doing is we're using those to give our flavor to the beer that we're gonna make, and then we add a specific amount of dextrose to give us the small amount of alcohol to be produced. I like to kind of call this engineered wort, because we are very much specifically, we know what we're putting into it, we know how much sugar we're getting into it, and we basically, using that, we can also know how much actual fermentation we're going to get. So we can very much engineer how that beer is going to ferment. This does limit the kinds of beers that can be produced, and the overuse of some malts can result in very acrid products. So if you're trying to make a stout, I've had a lot of alcohol-free stouts that can end up being quite, they're very, very roasty, and you can end up overdoing it by just trying to add too much of those specialty malts to it. So that's the wort production side, and then we can get into the fermentation side of things, where what we can do is use certain techniques or things available to us to control how much alcohol is produced. A very traditional approach is arrested fermentation. This is used quite commonly in Germany, where they will, Germany and Austria, to produce their alcohol-free beers. The use of maltose negative yeast is another option. There's a few that have hit the market that are, there's a few that have been on the market for a while and a few that have come out, and I believe one of them is under a patent. And then there's the engineered wort with regular yeast. So the engineered wort with regular yeast plays into the previous slide, but that is, again, tying it together with kind of using the way we control our fermentation. So arrested fermentation, Stiegl Brewery in Salzburg uses this technique. So what they do is arrested fermentation is you do your fermentation at really cold temperatures for about 24 to 72 hours. One of the things this does is it helps prevent your fermentation from getting away. And then after an apparent degree of fermentation of about 10%, which yields less than 5% ABV, the fermentation is interrupted. That interruption can be a bunch of different ways. It can be crashing. It can be you are taking the yeast, running it through a centrifuge and a filter, and then sending it into another tank and then aging it. And then also one of the things you can do with that is also pasteurize it. One of the advantages of this is that it helps preserve those hop flavors and aromas, but it doesn't really taste like beer. It tastes like wort. Both Stiegl Freibier and Stiegl Sportweiss, they smell really, really good. Like there's lots of hop aroma going on in there, and it does smell pretty malty, but then you taste it and you're like, yeah, this tastes like wort, like low gravity wort. So it isn't really beery in that sense. So it can work if that's what you're looking for. And if you are working within certain constraints, it can work for you. But if you're looking for beer, I don't think you're going to necessarily convince people that this is a beer product. So, but it is fairly simple that you can implement in your own setup. So maltose negative yeasts, These are strains that are incapable of fermenting the main sugar, maltose, which is the main sugar of wort. Depending on the wort position, it can result in beers that are still quite sweet. However, the beer does taste beery. One of the problems with any maltose negative yeasts is they, at least with the one here, Saccharomyces ludwigii, they're extremely difficult to grow, and a lot of them they don't flock very well, so it's really hard to even grow them up and then even crash them so that you can use them. And then another thing here is any other yeast is a contaminant. So when we grow these yeasts, we actually have, so we have 3 risk levels. We have risk level 1, 2, and 3. 1 for regular yeast, 2 for POF, and then 3 for diastatic yeast and Brett and all that kind of stuff. This actually, we had to introduce a new level, which is 0, because if anything else gets into this, it can have an extremely negative impact on the beer. So you need to be really, really careful with these. Saccharomyces ludwigii is a pretty popular strain that's used by a lot of alcohol-free brewers. It does work, but we are doing some research. I did some research earlier this year with some other strains. We're trying to find other yeasts that can work as an alternative to this one, because like I mentioned, one of the big problems is that it is quite difficult to grow. And we're just trying to find other things that result in some good flavors. Of a bunch of the ones we tried out, another thing that can come up is you will get a lot of off flavors from their fermentation. So they do their little bit of fermentation, and we found a lot of the other yeasts that we had used. We ended up with some DMS. Diacetyl was quite prominent in a few of them, and then others, they just didn't taste like beer. They still had quite a worty taste to them. And then engineered worts with regular yeast. So this is some homebrew I made like a year ago. Basically it's just steeped grains, throw in some extract, and then ferment it with kali or whatever. So the wort has little or no maltose or maltotriose in it to begin with. You can use the regular yeast to ferment, and then there's little to no residual sugar concerns for contamination, such as diastatic yeast. One of the things with this is it's a suboptimal yeast environment, so you don't want to be harvesting these yeasts to reuse them later. This could be something where, let's say you're in like Gen 5 or 6, or you have a bunch of extra yeast kicking around. You can make this low alcohol wort and then just shoot some of that yeast. And you don't even need that much because there's less fermentation going on anyway. So you can pitch at a lower pitching rate because you don't need as much yeast in there to begin with. So this is a way that works. It does taste beery, but there is sort of this like biscuity thing that goes on that I've sort of had commonly with a lot of the alcohol-free beers that I've tried to make. But it works. It's a really easy way to try something out, and it doesn't really require changing anything with your process. So post-fermentation handling is extremely important. Low alcohol products are missing a lot of the features of regular beer because we're working. Depending on how things go, you're probably still working at a pH maybe around 4.5, but it could be higher. There is the risk of food-based pathogens surviving in the product, and also because there's a lack of alcohol. So the yeast aren't creating that kind of dangerous environment or competitive environment for those yeast to survive in. And again, those depending on what your process is, you can end up leaving higher terminal gravities in there with a lot of residual carbohydrates for beer spoilers, such as lactic acid bacteria, pathogens, and other beer yeast to actually continue fermentation. So post-fermentation handling, carbonation, bottle conditioning really isn't an option for low alcohol beer. Some alcohol-free yeasts are Crabtree negative. So the Crabtree effect is whenever like regular Saccharomyces is whenever it comes in the presence of simple sugars, instead of starting to produce biomass, it'll actually produce a little bit of alcohol and then start producing biomass. These alcohol-free, or these some of these maltose negative strains are Crabtree negative. So what happens is immediately in the presence of sugar, you get a bunch of biomass production. So this was an alcohol-free beer. I think this was with Cluveromyces marxianus. I did the bottle conditioning, and then I ended up with like a half an inch of crap at the bottom that that resulted in these fluffy bottoms. And the problem there is whenever you open it, all that stuff is just going to get like roused, and the beer tasted fine, but I didn't want to drink it because there was all this floating particulate in there and it looked super gross. So that is one of the problems with it. So forced carbonation is the best approach to ensure that beer is within specification. And it's also, to prevent these kinds of things from happening. So post-filtration or post-fermentation handling, filtration and centrifugation. So we want to remove as much yeast from the beer as possible to less than 0.1 million cells per mil of beer. Especially for beers made with arrested fermentation. Sterile filtration can be used to remove beer spoilers as well. Something to remember with this, though, is filtration and centrifugation aren't the end point of your process. So there's still the risk that you can pick up contaminants from your bright tank into the package. So these will help reduce those microbial loads, but there is always the risk of something still getting back in there. And this is why it brings us to pasteurization. So pasteurization is it's the best way to make sure that your product remains as stable as possible, because sterile filtration still has the contamination risks that you have a sterile product and then you set it into a bright tank and maybe it has like blind spot, it has shadows or something, but there's something down the line that you do have the risk of reintroducing a contaminant. So pasteurization does protect your higher final gravity products from fermenting in the package, because you are running it through and then you're basically killing everything. So you're turning it into a nearly sterile product. However, you do, and this is with all forms of pasteurization, you need to have really good dissolved oxygen management. Otherwise, you can result in drastically decreased product quality. And then for alcohol-free beers, you're looking for 80 to 100 pasteurization units to ensure that the product is as stable as possible. For a regular beer, it can be lower than that, around, I think it's 10 to 20. There's a link to a presentation from the District Ontario talk where I get some of this information from that you can look through. And then quality control. So you need to define your critical control points. You need to define what your critical control points are and put procedures in place to monitor them. So some of those critical control points can be your specifications, your wort and beer pH, what your original gravity is, your attenuation, your ABV. These are pretty obvious ones. You want to make sure you're tracking your pHs, because that can let you know if something's going on, if you have a contamination. Your original gravity is important, because if you're over specification, you're going to end up, and you, depending on your process, you're going to end up with more alcohol being produced. Attenuation, again, that's monitoring your alcohol production. And then ABV, if you go over that 0.5% ABV, you are no longer alcohol free, and then that puts you in a different tax bracket. And the big thing there is you don't like the alcohol, like your alcohol control agency will do random testing, and if your product turns out to be higher alcohol, you can end up getting hit with fines, or you can end up losing your licenses and stuff like that. So you want to be making, especially with these kinds of products, you want to make sure for alcohol free that you are very, very much within specification. Microbial testing, you want to make sure that you're working, you want to make sure that you've got good yeast purity. You want to make sure that your post-filtration stuff is within specification. You want to make sure that your pasteurizer is working properly. And then you got your physical quality. So you want to validate your pasteurizer. There's these little machines that you put in with your product that are called PU, pasteurization unit testers. Basically, they just have a little probe and you run it through, and then it spits out a value at the end saying during this run, you created 80 pasteurization units. And then also you want to make sure that you have good cleaning procedures, especially if you're going to be using your tanks if you don't have dedicated tanks for alcohol-free product, then you're going to definitely want to make sure that you have things in place to make sure that your cleaning procedures are producing tanks that are devoid of anything, so you don't have to worry about stray yeast doing additional fermentation. And then for micro, So failure to control microbial quality of your product can result in expensive product recalls. That's the last thing anyone wants to deal with, especially now. But you never want to deal with a recall because it's just, you've already spent all this time putting it in a product, and now you have to figure out where it all is. And then depending on your jurisdiction, there can be a lot of other things in place involved with the recall. And then you can also, as I mentioned earlier, you can also possibly face fines for ABV violations. So by doing your micro, you're ensuring that your product is safe and stable before it leaves the facility. And then this is something I did for a trial we were doing internally. But we were doing our standard plating, and then we included McConkey agar. McConkey agar is a media that you can use to test for waterborne pathogens, so E. coli and that kind of stuff. And with alcohol-free beer, E. coli is an actual concern. It's a higher risk because of the type of product you're making. So you do want to make sure that you are testing for additional contaminants along with that. Normally you could use that, like let's say you're just testing your incoming water, but you might want to integrate that into an alcohol-free testing program as well. So in summary, there's a lot of business opportunities with low alcohol beer. However, it comes with a lot of challenges. Quality. Make sure you have a program in place before you start implementing alcohol-free beer. They need to go hand in hand. And an alcohol, the quality program is going to be getting that in line and making sure that you know what's going on and how to do your quality and how to check all of that is really important. So it's not free real estate. There's money to be made there, but it's not, you can't just walk in and do it. You have to make sure that you're being very prudent in how you're doing it, just to make sure that you are protecting your brand, you're protecting your consumers, and you're just doing all these things to make sure that the product is as good as it can be and it's as safe as it can be for everyone who's involved. So that's the talk portion. I'm going to bring Nate back in so he can start going through questions. Appeared on screen. So we're going to bring Nate back in. Thank you. So we're bringing Nate back.
Awesome. That was great, Chris. Thanks. That was really informative. As Chris mentioned, we're going to go. There we go. There we go. We're going to go through some questions now from the chat. Before we launch the questions, I just want to mention a few different things. There's a bunch more education that we're going to be providing over the next couple of days. We obviously have the conference going on for the rest of today. Tomorrow, we'll be focusing on mainly controlling flavors with a handful of talks on diacetyl, which I'll be giving tomorrow morning, THP, which Richard will be giving, and then Brettanomyces fermentations, which Caroline will be presenting. On Wednesday, we'll be covering quality control with a live cell counting demo with Chris here, as we have today. We're doing some lab tests you can do without a lab, which will be given by Alex. And then myself and Richard will be giving a talk on Diacetyl 101 and why you should be worried about it. Before we jump into the questions for today, I do just want to try and emphasize, I want Chris to try and emphasize something. What can happen if you try to produce a non-alcoholic beer in a normal beer fermentation facility and you don't take into account the proper steps required to ensure it's sterile? I want you to kind of map out kind of a worst case scenario on this. What's going to happen if I have a ton of non-alcoholic beer that has a Saccharomyces contamination in it and you release it to the public?
So depending on the final gravity, you release to the public, and the way our supply chain works is things sit warm. So you will end up most likely with exploding product, or you'll probably end up with exploding product. If people are getting to it fast enough, but not fast enough, you'll end up with extremely overcarbonated product. But that'll probably be the big thing. Oh yeah, and higher alcohol, which will push you out of specification. And then if you are, because the big motivation for doing this is you can sell a product that's beery and you can sell it at a nice kind of craft markup, and you can still make there's a nice margin to be made there. But if you do that, you end up you get caught, you can end up paying fines, and then all your margins are gone. So
yeah, exactly.
So it's
or having to go through really expensive recalls, or having giant messes at grocery stores and things like that, which then cause huge problems. Like the biggest thing I personally foresee with this topic is that the standard things, and you said this in the presentation, right? I just want to make sure we try to emphasize it.
Yeah.
The biggest issue you see with this is that you can't treat it like normal beer. No, it has to be treated more akin to like dairy.
It's like that, or like soda or something, right? It's not. It's a product that depending on your process still has a lot of residual sugar in there, and like if you don't make sure that product is sterile or doesn't have anything in there that will ferment it, you are going to end up with a product that will ferment and explode, or ferment and create more alcohol, and then it's just you don't want to be doing that. And also, like if someone's going, like let's say someone doesn't drink alcohol, and then they go and like maybe like now you're also disappointing your customers because they're like, I thought this was an alcohol-free or reduced alcohol product. So
yeah, absolutely.
Usually people are drinking these products, like let's say they're designated drivers or something. There's a lot of reasons why these products do exist, and we want to make sure that people are getting what they pay for. So
yeah, absolutely. And I think this is a huge market we're going to see expand, and whoever can kind of nail this thing down and get good at it there's a huge market on it. Like if you look at the UK right now, there is what is it? I think it's Brewdog's, Nanny State or something like that.
Yeah,
is a massive brand for them. It's one of their highest production brands, and it's all alcohol free or near beer, effectively.
Yeah.
So we'll start going kind of through some of the questions. So first off, what's your favorite non-alcoholic beer?
I kind of have like two angles I come from that. So if I want affordable, I go with PC Blonde Brew because it's actually pretty good. If I want to go with good, I found the Weihenstephan Helles Lager is probably one of the best alcohol-free beers I've had. The stuff I had from Athletic was quite good. But I'd say in terms of a beer that tasted like beer that had no alcohol in it, the Weihenstephan Helles Lager was probably the best one I've ever had. The only problem is that it costs like $5 a bottle. So
okay.
It's a weird treat, I guess.
The next question. A lot of companies use lactose as a non-fermentable sugar to bring body in non-alcoholic beer. Could you use maltodextrin instead to avoid that kind of sweetness characteristic? So still giving body, but not overly contributing in sweetness.
Yeah, like you see maltodextrin is also used in what's it called? Gluten-free beer. I know Glutenberg uses maltodextrin in quite a number of their products to add body. As if you're following good procedures and making sure that like you're doing like pasteurization or still filtration and stuff like that, I don't see why maltodextrin couldn't be an option to add body while not adding sweetness. Maltodextrin, depending on the people, can give them gastro issues.
Yep.
So there is that. But maltodextrin can work, and it is an option, and regular, like the reason why people use maltodextrin in other beers is because regular Saccharomyces can't ferment it either. So if maltose negative yeast also can't ferment that. So it is an option to use as well. And then maybe again, tying that into that engineered wort thing, using maltodextrin as the thing to bump that gravity up could work.
Yeah, I would also, I can't believe I'm about to say this, but using things like low-level crystal malts could also potentially achieve a similar thing.
That alcohol-free beer, that picture that I showed I used crystal malts in that, and it was okay. Like it was like a, I think Pat described it as he's had worse IPA or worse pale ales. So like worse pale ales that were 5% alcohol. So like it, you win some and you lose some.
It's an option for it.
Yeah.
Next question. I've had some commercial beers brewed with Saccharomyces codes ludwigii, and they all tasted like raw wort to me. Is this typical of the yeast / process? And I'm going to add a bit on here saying, or did something go wrong?
I think it's the process. Like I've used like in like engineered worts, I've used Saccharomyces ludwigi. It really depends on what the finishing gravity is, I think. But that is a big challenge with using these maltose negative yeasts is you need to make sure that the wort you're producing isn't just full of maltose, because now you're basically just making like malt soda. And so it's probably a combination of both. And that's the really hard part of using the maltose negative yeast, is making something that tastes like beer and just doesn't taste like raw wort. So it's probably a combination of both. That's like, it's hard.
I have a follow-up question for this. If you want to learn a bit more about how to handle kind of standard fermentations, I'd recommend you go to our Yeast Basics series, 3 parts. Can you give us kind of a very basic rundown as to how you'd use this? Like, do you aerate this strain, the Saccharomyces ludwigii, Saccharomyces coatis ludwigii? Like, is it?
I don't.
Okay, that's fair.
But I'm lazy.
A lot of the stuff is still unknown.
When I've made it, the aeration I've done has been just the aeration of putting it into the vessel I'm fermenting in,
right.
And like the aeration I've gotten from cooling it down. So just regular like homebrew style aeration. In a production facility, I'd probably just aerate it as normal.
Right. So for most the alcohol beers, you're essentially treating it like
I would
beer.
treat it like normal. Yeah, like the yeast still needs to get that. Like it's still yeast, so I'd treat it the same. I haven't played around with anything like this where I'm doing like, how does it taste when I don't add oxygen to it versus when I add oxygen to it and all that kind of stuff. So it's been really like, now, a lot of like the stuff I have done has been, we're just trying to find alternatives to Saccharomyces ludwigi that also taste good and are easier to grow.
Yeah. Or easier for people to actually ferment, like produce beers with.
Yeah.
Next question. Have you any experience with diacetyl production or reduction in arrested fermentation beers? And this is from Pratt.
So I haven't done arrested fermentation. I wouldn't be surprised if that is a thing. I've really done the alternative yeast or engineered wort approach. So I haven't done arrested fermentation because I know that my process, which is I'm doing homebrew, doesn't have anything in place for arrested fermentation to even work. So I could crash it and then like transfer it, but there's still tons of yeast in there and I don't have a filtration setup. So I have in our alternative, as I mentioned, with our maltose negative yeast, we have had Diacetyl as like the beer, like, so a few of them, I don't remember which ones, but the original gravity of so that one I showed with the picture of the 2 converted worts, I had an original gravity of 1020, and then a lot of them only attenuated 0.5 degree Plato, and quite a number of those had like about half. This was across 8 strains. About half of those had either DMS or diacetyl. So it's very much dependent, and I think that's what it was. Is they chewed through all the fructose, and they weren't, or the glucose, and then they weren't done, so they didn't get to clean up after themselves. So they just ended up leaving a bunch of diacetyl in the. Do I think ALDC would work?
Just before we get to ALDC.
What is it? It's the thing. It's an enzyme that you can add. So the way it goes is there's like, it's something, and then it's diacetyl, and then it's converted. It basically shortens that. They use it at Granite for some of their beers, but it's an enzyme that you can add that will, thank you, acetolactate decarboxylase. That it basically takes it prevents the diacetyl from getting created at all, and that could be something you could try. And it probably would work. Like Ringwood brewers use it. I don't see why you couldn't use it as a tool for, like, these are tools we have available for us and we should use them. They are, if they make things easier for us and they also provide us a more consistent product, I see no problem with that.
Yep. This is next question. What's the lowest attenuation yeast? Which strain do you suggest we use if we're trying to go with something like this? that tastes good. I put the caveat in here that tastes good.
So the only one, like, there's the whatever the yeast is that Heineken 0.0 uses. I think it's a Pichia, but I'm not sure. It is patented,
Okay.
but that is one. Like, and I found, like, I've had the Heineken 0.0, and like it's kind of banana-y, so, but it's nice. That one's pretty good. WSL 17 is nice, but yeah. And then there's a few other ones, but we haven't done any further. Like, I haven't had a chance to do more research on them. But you basically want something that'll ferment like 0.5 degree Plato. But yeah, there's this, it's called Buch Hanseníaspora and then Welli Uverum. Those ones were both positive, but those are internal names and they mean nothing. And we haven't turned them into products.
We haven't commercialized those.
We haven't commercialized them yet. So more work is required, but those two showed some promise. There's this other one that Richard heard about called Cyberlindia fabiani. My tests were done at 15. It was still quite ethyl acetate. The plates, whenever we grow them, they smell like nail polish remover. That might be something worth playing around with at like a lager fermentation. But that's, again, way more research is required.
Yep.
But those are probably that one was suggested, Richard, from someone at the European Brewing Congress.
Yeah, this topic in general, it requires a lot more information.
Yeah,
a lot more research.
Yeah.
One question I have this, and I'm going to add a bit on here. Would addition of lactic acid post-fermentation aid in arrested fermentation beer taste less like wort and more beery? Could this also help the stability of these kind of of these fermentations? Just adding some lactic acid, try and make the beer taste.
Yeah, so that can help. That can help. Like we've seen this with Kvike and stuff too. Especially with these beers that are finishing at like 1018, like 1018 or whatever, like pretty high finishing gravities. You can pH adjust them, and that will cut through that perception of body. So you can do that. That will work. One thing that also helps with that is upping your bitterness more than you think you'd need to, because that bitterness will also help fight the sweetness. So you still get body, but you also get more. You get more. The bitterness kind of gives you the body, but cuts through the sweetness a little bit.
One thing I want to add to this: so most of these fermentations we're doing with any of the strains we have, commercialized or non-commercialized, do we know what the final pH of these beers are? The reason I ask is like most things become quite more stable once below 4 pH, like things like botulinum toxin, E. coli, because we don't have that alcohol buffer to kill these things off. The pH should be lower just from a food stability standpoint.
Yeah, especially if you're not like, you can pH adjust. The thing is, it will have a flavor impact.
Absolutely.
We're not sure. Like, we tested some pHs on some alcohol-free beers, and they were pretty low. We're thinking that they are getting alcohol-free craft beers. And we think what's going on there is there's probably like phosphoric acid or maybe lactic, but we think it was phos that was getting dosed in to bring that pH down, and that will have a flavor impact on it.
Yep. That makes a lot of sense.
Well. Yeah.
We got time for a few more. When you heat the beer to boil off alcohol, the beer usually ends up tasting like crap. Another method is reverse osmosis, where you run the unit through a membrane. Is this something you could do at home?
No. That's really it's the RO systems are pretty complicated, and they require, like, RO requires lots of pressure, and I don't know if you'd be able to get that easily at a civilian level, I guess. I'd say if you could figure out a way to do at home vacuum distillation or whatever, or vacuum extraction, that could be an option, because you don't have to heat up the beer as much. And that's what is used by the big guys. That's how they manage their alcohol-free products. But I'd say if you can, like, try taking a yeast-based approach, especially at the homebrew level, because it's a yeast or like mash engineering approach because that'll just help you reduce that. Like you can reduce the alcohol through process or through ingredient selection versus trying to use engineering to get it out. And there was one a home brewer in Guelph did an alcohol-free New England IPA, and it was pretty good. And we tested it.
I remember that.
Yeah. There was like an issue with it had some meatiness to it because it was heated up and all the yeast died. But
this is a good question, a good kind of follow-up question for that. So one of the questions was, how do we avoid that kind of hop tea characteristic you can get with just a kind of steeping hops in water, or for beers like this? How can we avoid that just kind of hop tea characteristic of making low alcohol beers?
That's a good question.
My gut is to say limit contact time.
Yeah, that would help. Kind of, it's tricky. Like I don't know. I don't have a really good answer.
I would want to say make sure your pH is in check. Like if your pHs get too high from a food safety standpoint, that's bad for the style of beer, especially. But also, the higher the pH, the more you're going to extract things out of it.
Yeah, that's true.
Which isn't something you want to do. I probably would recommend also making sure your temperatures are a bit colder. But this is something we saw with Jeremy with Barn Cat. We're making sure if you want to really keep the softness for these beers, they recommend dry hopping at colder temperatures. So dry hopping like 15 to 20 degrees C. Don't let that thing get too hot. Limit contact time to like 3 to 6 days tops. Doing things like that should help kind of cut down that tea flavor you can get sometimes. We're going to do a few little wrap-up bits for here. Do you think genetically modified technologies could help this area?
I don't see why not. I don't see a problem with it.
If you can make it Maltose negative Saccharomyces, that could be really easy. That could be great.
Yeah. I think it's more of it getting accepted than we've already seen this with products like with the Saccharomyces, right? Like that's a GMO product. So it's just people will work on it and then it'll get accepted eventually, and I think that'll be fine. If it helps produce beers that taste good, I don't see why not.
Okay, I think we'll finish up with the two final questions. The vast majority of low alcohol beers in the market are clean beers, so to speak. Do you have any experience with low/no alcohol sours? I imagine something like a Gosa would have a greater capacity to hide some of the less ideal off flavors.
So this is something I've been wanting to do for a while. I want to make a alcohol-free dry hop sour. I think that would be killer. Like, I think you could do it. I know with some maltose negative strains, their fermentability increases in higher acidic worts. So that is something to be aware of. But it is something on my list eventually that I'll get around to make a alcohol-free dry hop sour, or like just an alcohol-free fruited sour, because I think that would be delicious. I don't know if you could do like super funky stuff, but I think doing like kettle soured things, I think that could be really fun. And it could make and also like those sour beers, especially a Goza, are like super thirst quenching. So I could see that totally being something that would be amazing. I agree. Oh my God. I need to, it's on my list of things to do. So yeah.
All right. Then I'll do a final question. This is kind of a summation of a handful of different questions we've kind of seen in here. Do you have any recommendations for cold mashing or trying to really limit the amount of amylase activity that occurs when trying to make a low alcohol beer? Like, is there anything, what would you recommend people do? I have some thoughts on this. I'm going to jump in at the end with if you don't cover, but how would you go about actually handling a low conversion rate mash for a low/no alc beer?
So what you want to do is, and this is how I've done it, is I've taken my mash and I put it in the cold room. Can't do that at a production brewery setting, but take the mash or you could just mash in with like cold liquor tank water, mash in, and then you just let it sit, and you just want to make sure that all the grains exposed. This works really well if you have a mash mixer and not a mash lauter ton, but just let it sit for 8 to 12 hours. That's what I've done. Basically, I get my grist together, mix it 5-to-1, and then put it in our cold room in a bucket and let it sit like that. And then I do wort separation, move it over to my kettle
water?
for, no, I don't. Or have I? I can't remember. But I think for some I have and some I haven't, or I do a little bit. But whenever you're sparging with cold water. You're not sparging with hot water. And what you could do for that is, let's say you have a mash mixer and a lauter tun. You just add all of your sparge water to your mash mixer. Hopefully you aren't overloading it. And then you mix it all together, send it over, Vorloff, and then collect into your kettle. Do conversion in the kettle. You could not do conversion and you'll end up with a less fermentable wort, but it's going to end up being super starchy. So do a conversion. You're only getting you're going to be using you're going to get a quarter of what you would normally get out. So generally I've targeted for 10-20, and then using regular yeast, I get about 2.5 degree Plato attenuation, which works. But you could just do that and then ferment it with a maltose negative yeast.
So how much variance in product would you see though? My big concern with something like this is that if you say your process is 30 minutes longer because something else happened downstream of this.
If you're I think the main the risky part would be the heating. I'd say that's the part that you have to worry about the most. Once you hit conversion, or once you're satisfied with your conversion, you could then start heating it. Depending on again, it all comes down to how your system works and how long it takes for things to ramp up. That's kind of where the challenge is. But if you can ramp things up fast, you're probably okay. If things ramp slowly, what you could do is control that by, let's say you know that it takes you 30 minutes to go from 60 to 80. You could just do your ramp and then do that a few times. And if you consistently know that by the time you're done your ramp, you're converted, then you're fine. Then you can just be like, I ramp it, and no matter what, I don't worry about it. So that's kind of how I would take a look at it as well. But everything I've done has been on small scale.
From a commercial standpoint, you'd have to have those times locked in.
Yeah, you need to know what they are. But if you I'd say working on a ramp is probably better.
I want to finish on one kind of question that comes to mind. So you mentioned Athletic, not DL. Do you have any idea as to how they produce these beers?
I did some testing. So what we know is that there's something going on because the product did not grow on anything. The pHs were below 4. Those were the two big ones. And we're pretty sure, because everyone was tasting it, because I was like, hey, I brought these beers back, and then everyone was tasting it, it's got a tea-like thing. So we're probably sure it's getting pasteurized in some form, and they're pH adjusting. Those are probably the two big things they're doing, but they're good. So they're tasty. Yeah.
Yeah, I imagine as some time goes on, we're going to hear a lot more kind of progress on this topic. So
I think so.
With that, I want to say, Chris, thanks a lot for kind of sharing all this information for us. We'll be posting this video to YouTube later on today, and if you have any more questions, you can ask them in the video over there on YouTube. And again, Chris, thanks.
All right.
Cheers. Right after this, we have the next talk, which is a fireside chat with Lars. If you guys want to stick around, that'll be coming up at noon. Take care, everyone. Cheers.
Good. Bye.